got some poles. Oh, yeah. I had my safety class today, so I'm just wearing the same stuff that I had to wear for class. That's why I'm dressed. I normally don't dress like this unless I'm working. Yeah, so we had to cut some wood, use a tape measure, use a handsaw, cut a conduit with a hacksaw, identify tools. What else did we do? Or check if a level is actually level, which is pretty cool. I never realized this. If you put a level up, and it's spirit level has a bubble in the middle, and you mark a line here and here, and then you flip it around the other way and do the same thing, the lines should match up, and a lot of times they're off, so the level isn't actually really level. So, yeah, there's an older lady in there, she's like 70 and left-handed. She had a really hard time cutting a 2x4. She was just like, you know, like little baby cuts with the handsaw. Yeah. Boy, another small class today. Well, let's get started, I guess. Will it come in late? Let's see. All right, let's reach together, control. All right, what we're gonna do today is go over these poll questions. Angel. And then Richard had a question about what was due today, lab 2, with GitHub. So we'll go into that a little bit, okay? Just so you guys understand how GitHub works and how you can create a branch, stuff like that. And then I've got a little assignment to do in class where you're gonna type up a little Python script to find the minimum of 3 numbers. And then I'm gonna have you guys break into your groups. You're gonna have 5 groups, and you're gonna do another kind of a little more challenging assignment that we didn't get time to do yesterday. Okay? Karen, right? Let's see. Get that. Okay, let's start this out as people walk in, it's okay. In Python, garbage collection deletes the memory used by previously declared variables that have been set to another value. Is that true or false? So most people think it's true. So you guys remember, we said something like yesterday, if I say X, oh yeah, crappy. I'm gonna get rid of this guy. Man, who took, oh, I know what happened. I took one home by accident. It's my fault. I stuck it in my pocket. What if I put it back in here? What's this? Nope. Nope. Oh well. It must be somewhere else. Okay, so I said X equals like 5, for example. And then, you know, I could do print X, and that's gonna print out 5. It's an integer, dynamic typing, right? It sees this as a 5 and it automatically says that's an integer. And then if I say X equals 10, and I could print out X or whatever, I could say print X here, and that'll print out 10. So what happened to the 5 that was stored in memory? So this is what we talk about garbage collection. 5 is sitting out there in the memory somewhere. It was bound to X, but then I rebound 10 to X now. So this 5 is sitting out there. We don't care about it. It's not associated with any variable. So why leave it there? Why keep it, right? So we're just gonna get rid of that and free up that memory. So that's what garbage collection is. So you guys that got that answer got it right. Hi guys. Let's let some more people in here. Okay, good. Let's get back to this second one. You in this one? I actually have 8 polls today. Okay, let's launch this. What is wrong with this statement? False is set equal to 5. Is that okay to do? Is that a valid statement? Or do you have to set false equal to a Boolean value? Or is it that you can't name a variable using the name of a keyword? Looking good, guys? Looks like you're getting this stuff. Let's see. Make sure you guys log in.
I was thinking function more than keyword.
What did I do here? Okay, get that. Joel. There we go. What the heck? There we go. Okay, so the answer is the third option here. You can't name a variable using a keyword. So false is a keyword. What would be another keyword?
True.
True, yeah.
Print.
Print, yeah. Anybody else? Any other keywords that we've already learned so far?
Print. Oh, print.
Print, yeah. Yeah, we haven't learned a lot yet, but how about ORD? Remember we learned ORD? If we said ORD A, that gives you the ASCII number 65. So you can never name a variable the name of a keyword or a function that exists. So it's good to know. Rashid, oops, let's let you in. Okay. Okay, good job. I hate when I have to let somebody in, I have to, it like kicks me out of my window. Okay, great. So that's, we're gonna close this one in the poll. So you guys got that right. Poll 3. What is this type of a comparison called? X is greater than or equal to 1, and X is less than or equal to 5. Is it a simple comparison, an if-then statement, or a chaining comparison? And some of these questions are going to be on the 3rd quiz, which isn't due until February 20th. So you have a little time. So we're starting to get out of chapter 2 a little bit. And I think we're going to finish chapter 2 today. Okay. Yeah. Okay, so you guys that voted got this right. It is called a chaining comparison. We're chaining this X. It's a simpler way to check if X is between 2 values. Okay. Somebody voted for an if-then statement. So let's look at an if-then statement just for kicks. If I say X is 10, and I said if X is greater than 5, then I might just say print, whatever. I'll just print hello. It doesn't matter. So this is an if-then. If, and this thing is an expression that has to evaluate true or false. In this case, 10 is greater than 5, so it's true. So it does execute this thing that's tabbed into. So this is if, and then the colon, you could call it then. If this is true, then do this. Okay, that's what if then is. If you guys have questions, just Shout them out. Okay, let's fire up poll 4. What does the following statement evaluate to? 5 is greater than or equal to 5. We could put that over here. We could change our little if thing and say, is 5 greater than or equal to 5? Because this is an expression, it's gonna evaluate to true or false. And you guys got it. So 5 is greater than or equal. It's equal to, so it's one or the other. So this one is true. So in this little baby Python script right here would print hello. Hello. Hey, very good. Okay, poll 5. What's wrong with the following code? It didn't, I feel like I'm gonna sneeze here today. It didn't print out the way I wanted it to. So I'm saying, I'm gonna reprint it here for you guys because it looks kind of goofy there. My total equals 10. So that's an assignment statement. And then I'm saying, if 10 equals, if my total equals 10, print your total as 10. Indent. Else, print your total, that's right, is not 10. I think that's what that says, right? Let's get rid of this part. Okay, so what's wrong with this statement here? If anything. We got 4 votes for that. We left 2 people in here. Antonio, Carlos. Good, let's get back to here. Okay, some people think I need to change the equal to a double equal and put a colon after the else. Okay.
Yeah,
Some
no.
people think you should use double quotes versus single quotes here. Okay. All right, good. Some people think nothing, it's gonna work just like this. Okay, what do you guys think the correct answer is?
I think that one.
The second one? Okay, Tony, go fix it. On the whiteboard. If it's wrong. It's okay.
Yeah.
If you make a mistake, no biggie. Okay, interesting. All right, good. Colon there? Okay. Okay. Is that a colon or a semicolon?
Oh, it's similar, right. Like this one.
Okay, good, thank you. Okay, did Tony do a good job? Is there anything else? Is that gonna run as is?
Good.
I don't think they're top.
thought my total was supposed to be double equal, was it?
It's
That's
no
just what
longer
machine
defined
told
now,
me.
I think.
This one's not supposed to be double equal? How come?
Because that's what the program's telling you that the input was, so.
Yeah. So we're gonna set my total equal to 10, right? So we just need one here. Yeah. But everything else you got right. Good. So we're setting my total equal to 10. This is an assignment with a single equal. And now we're checking. This is an equivalency. We're saying, is my total equal to 10 or 2? And then we've indented, we say print. Do I have to use double quotes? No. Single or double, it's the same.
There is a strange thing though. In the first set of parentheses, you start with double quotes and end with single quotes. Oh wait, no, I'm misseeing it. Never mind.
Yeah.
Oh, okay.
The parenthesis looks like a quote when I'm not looking at it correctly.
Yeah, yeah. And then this else needs to have a colon after it, and then we have to indent that. Good. Okay, you guys got that? Very good, because we'll be doing that today. A little more writing of code with if-thens. Let's end this poll. Let's see, somebody else wants in. Let's get in, whoops. Oh, here we go. There we go, all right. Okay, let's get that in. All right, that was this one. All right, here we go. All right, so whenever you see something like this, the value of 7.5 modulus 3.5, you can type it. I would open up VS Code right when you get into class. And then you can type these things in the interactive window and see what the answer is. I would do that. So remember, this is the modulus, and what does it give us again? Anybody remember?
The remainder after dividing the second number from the first.
Yeah, yeah. Gives us the remainder. So has anybody pulled up VS Code yet? Try it. We can do it by hand too, but. Anybody verify it?
Okay.
Tony?
Yeah.
You got it?
Yeah.
True,
Yeah,
okay,
true.
good. Yeah, that is true. So when you guys take these tests, these quizzes, just open up VS Code, it's all open book. Just type in the stuff, right? Everything's open.
No, it's supposed to be what's that sign? Are you in Python right now? Yes. Oh, yeah, you might want to do that, but your first one is 7.5. What do you mean, 7.5? And space, yeah. Oh, yeah, I think it's and then 3.5. And then enter.
Okay, you can use the remainder operator to determine whether a number is odd or even. Is that true or false? I think Fernanda had that as one of your group projects, right, before? So, you remember what it was, Fernanda?
I don't, I was just trying to remember that from last question.
Say I said x is 10, and then how would I determine if x is odd or even? If x mod what equals what? Then I'm gonna say, print even, and make it simple, okay? So what number divided by something is gonna be equal to something that's even? Anybody remember? Use it. Remember? If I divide any number by 2, and the remainder is 0, right? Evenly divisible by 2, it's even, right? And I could just say else print odd. Right, so that's how we use the modulus. This is the modulus. Oh, I screwed this up too. What's wrong with my statement here? Anybody see an error?
So, two equal signs?
2 equal signs, yeah. Now, since I've been like a programmer for so long, and years and years and years. I'm like a human debugger. I can just look at somebody's code and like find the problem in it. And you guys will get good at that too. Like you'll be able to just spot errors quickly. All right, our last poll. Let's launch it. And then we'll look at GitHub a little bit. The value of the expression 7 plus 3, and these are single quotes, is the what? Is it the integer 10, the integer 73, the string 73, or the string 10? So I'm trying to say, what is 7 plus 3? Remember we talked about overloading an operator? This operator, the plus sign operator, is overloading. So what does it do when I have strings? Anybody remember the word?
Concatenate?
Concatenate, good. All right, so that should tell you, concatenating means put two things together. So what's the answer gonna be here? I'm putting two strings together, mushing them together. So I'm gonna just get 73, one string. It's not a number, it's a string. All right, so that third option is the right one. So some of you guys thought we're gonna add it, but you can't add strings together. It sees that it's a string. Python will see, hey, I've got a string and I'm trying to add it to another string, and it says, I'm not gonna use the regular plus sign. I'm not gonna try to add it. I'm gonna concatenate. Okay, cool. Any questions about all that? This is a little review, but also some of these are right out of quiz number 3, which won't be for like another week and a half. Okay, let's, any questions? Yes, sir? Let's look at what was due today for a second. Where's my? Oh, I see. There we go. Here, let me display my laptop up here. Let's see. Okay. Okay, can you guys see my laptop screen? Okay, cool. All right, so GitHub. So this is, let me just, I'm gonna go ahead and get out of here. I'll get all the way back in. Log out. Okay, sign out. Okay. So just open a web browser and go to github.com. Let me make this full screen. Hopefully you guys can see. So basically to use GitHub, you just type in github.com. GITHUB.com. And then sign in. So you gotta create an account. Let's see, let's remember mine here. I'm using my Arbrise 3 for this one. Whoops, didn't like it. Hang on. Yes. I thought it was Arbrise 3. Let's try this one. Oh, might be this one. Okay, let's see. Forget my password here. Oh, there it goes. Okay, I'm in. Okay, so once you get in, it looks like this. Okay. And right up here, you can say, I want to create a new repository. A repository is like a little project area. So you can pull this little plus sign and it says new repository. I've already got these repositories over here. Well, just two of these are mine. One's called Hello World and one's called CIS 129 Hello World. So let's create a new one. And I'll say new repository. Okay, and it says, oh, let me make this bigger for you guys. This is a little bit better. And it says, my owner is Arbryce3, and repository name, and I'll just say class test, whatever, class test. Okay. And this is my, and a description, it's optional, I'll just put class testing of GitHub, repository. Right, whatever. And then I'll make it public. You can make it private or public. And I think they want you to add a README file. Okay, and then you click this button that says create repository. So now you can see I've got a new repository over here. Arbryce3 class test. So that's my repository right there, and it's public, so anybody can see it. It's got one branch called main, so everything starts with main. You're going to find out about main pretty soon in Python. So you have one branch, so you can think of this as like a tree in a way. And this is called a version control. If anybody's ever heard of that. Has anybody heard of version control systems? Version control. So it's a big thing in computer science where if you're working with a whole bunch of people on a big project, this would be more like Microsoft and stuff like that, big companies, but little companies use it too. So maybe Tony and Tim and Carlos, you guys are all separate working for a company. And we have a main branch. This one's called, what do I call it? Class test. Right? And think of this as a tree, and then under this tree, like Carlos could create his own branch. And Tim could create a branch. And Tony could create a branch. And then they could have some stuff under here. And you might have another little branch called code editing. And in here you might have Python 1.py. And you might have a code edit here. And in there you might have a Python 1.py. You guys might have the same file that you're working on. And what a version control is you've made a copy, you make some changes in here. Yours might say print hi, and yours might say print by. That's the whole thing. And you guys want to merge those. So say up here I had Python 1 up here as a master, and you guys copied my master down into here. You can merge your two versions together and push it back up to the top, and then this Python 1.py would say print hi and print by. Okay, and then Tony could check it out, and he would have now Python 1.py, and he could add another line that says print see you later, whatever, something like that. And then he could merge that back up to a master and then it would say print high, print by, print see you later. So everybody could work on their own thing, make their own changes, and they call it a pull request when you create a request to pull it all back together. So this is how you could, what they call a fork, they call it forking. You could fork off from the master, do a whole bunch of changes, and then do a pull request and push it back up. So you could, theoretically, all you guys could do that. I could create something, and you could all fork off of mine, make your changes, and then push it all back up. We do this in GIS too. People could work on the same, we call it a feature class, like a polygon. Like say somebody's editing a polygon that looks like this, and that might be somebody's parcel, their house, their land that they own.
I need to take a call real quick.
Okay. And then I would check it out and create my own copy of it, and maybe I edit this line because it was actually wrong, it meant to be here. And then I would change it, and say somebody else worked on it, and they edited, and it used to be like that, and they took out a piece and they said, oh, this really should be a cutout right here. Then we could merge the two together. We could all be working on the same one, merge our changes back up into the master, and then the master would it'd have both of them. So it would be this, my change right here, and then something like that. Okay, so this is kind of the same thing you're doing. You have your own little copy, and then you can merge it back together with the master. So let's create a branch. So the way you create a branch is you pull down this main thing, and you can, it says find or create a branch. So let's have one called code editing. Okay. Okay, there. And then, let's see, and then I say create branch code editing. I click on this little part. Okay, so now I have a new branch called code editing. Okay. And now I can create my Python file. Create new file. So over here it says add file, create new file. And here I'm going to name my file python1.py. Okay. And here I'm going to just start typing some Python code. This is a comment. This is python1.py, and I'm going to say print hi. Okay. And then what I do now is I say, I've made my changes, I want to commit my changes. So I click this commit changes button. And every time you make a commit, you can add something like a little comment. Like you say, well, I added print hi. So you know what you did. Okay, so there we go. All right. So now I have my repository called class test. I have a branch called code editing, and then I have a file in here called Python1. I click on it and I can see it. Unfortunately, I don't think you can run Python inside here. At least I don't know how to do that. Now let us make a change to this. So if you want to edit this, click this little pencil button. And now I'm going to say print by. Okay. Now I'm going to commit another change. So I've made two changes. Added print by. Commit that change. Okay, so now I've got two changes. Now we want to create a pull request to put the two together. So it says pull request up here. And I can say, I can do, it says code editing has recent pushes. They call it a push when you commit changes. Compare and pull request. So let's do this. Okay, add a title, I'm just gonna leave it like there. Okay, so it's gonna, it says able to merge, these branches can automatically be merged, create a pull request. And I can add a description, or I guess I could have added it before. This branch has no conflicts with the base. The base is the first one, and I could just say merge pull request. Confirm merge. And then I should see my updated Python one, let's see, in my, let's see, where's it at? Should be right here. Let's see. Yeah, so let's look at Python 1.py, and it should have both lines in it. Yeah, there it is. So basically, every time you do a commit, you're kind of creating another little branch. And then I just added my by, and now it's all, everything's been committed and merged together. So you can merge stuff from other branches and other people as well. Somebody could give you something and you could merge it into yours. Okay. And then how do I get a link? So what you guys have to do for your, what you had to do for today, you can still turn it in, it'd just be 10% late, is take a screen grab of this and then send me a link to this, which would be right here. You could just copy, once you pull this up, just copy that link right there. And this is public, so you could paste that in to your D2L when you turn it in. And I can go to your link. I've already graded some of your work. And the other class I'm teaching online is doing the same thing, you guys are. So this would give you the URL to get right to your Python code. Does that help a little bit? Richard, about how GitHub works?
Yeah, I think so.
You don't have to use GitHub, we just wanted to expose you guys to it. And a lot of people use it. If you go to get a job, it's good if you have some big programs you're gonna write. Like later on at the end of this semester, you're gonna write some bigger programs, maybe like 100 lines long. And you could put these here. And you could show somebody. You could say, hey, go to this GitHub link, it's public, and you could look at my code. I'm a Python programmer, right? So you could share it, it's all public. It's like you're getting a free web page in a way. There's also a way to like create, this is my little whatever icon that came up automatically. You could put your own picture there, and you could, I think you can create like a little summary page about all your skills and everything, and share that with people too. I've done it before, like a few years ago. I've got a couple GitHub accounts. Like when I took that Harvard class, we had to create GitHub accounts there too. I don't think we're gonna use, you're not gonna be asked to use GitHub, I don't think much more, other than what you just had to turn in today, so. But it is, everybody out in the field tells me that they all use GitHub, so. I'm a little late to the game. I've been programming for so long that GitHub wasn't around, so, but I've used other version management systems. At Motorola, we used one too, and when I worked at the county, we had one for GIS. So it's a good thing to do, to be able to get. You could also get back. You can go back to your previous versions too, if you want to. Okay.
So this is like an Indeed version of like computer programming, sort of like you can show like the add-on and like programs and that.
Yeah.
That's basically what I'm
Yeah. Yeah.
Also a great place to share programs, like I just have my background clock here. I wanted a kind of transparent clock and somebody made the code, and even though I haven't really contributed anything to GitHub, like it's just something that I got off of GitHub, so you can get other people's programs.
Oh, yeah.
Yeah, you can get a lot of stuff. I mean, you can get Linux, the whole operating system, and make a clone of it, fork it, and you can tweak it, make your own Linux. You know,
So, it's
call
just
it
like
Miguel's
the same-
Linux.
Is this the same program that like people use to like make video games? Like you know how you said like it's like a big flow person makes their own puzzle and they have another puzzle and they merge it?
Yeah.
Sort of like the
Yeah.
same concept.
Yeah. Yeah.
More advanced.
Yeah, yeah, yeah.
Okay.
People do this, yep, for sure. They use GitHub a lot. It's big. So there's a program called just GIT, that runs on your computer, and then GitHub is in the cloud. So the GitHub is in the cloud, but you can have just Git and download that to your computer and just do stuff on your own. But then once you go to the cloud, it's called GitHub. All right, cool. Now let's get to what I want to cover today, and then we've got some time here. Where's my, there it is. Okay. I'm gonna make this big, since I'm still using, can you guys see that? Okay. So here's what I want to cover today. We're almost done with, this is section 2.9, I think, in chapter 2. So we're almost done with chapter 2, so we're moving along well. I like to move along fast in class, so every class I teach, by the end, I'm usually 2 weeks ahead. And I let you guys decide at the end what you want to learn. Like last semester I taught at the East Campus, and the kids, or you guys aren't kids, you're adults, were so smart and good that we had completed everything and still had 2 weeks to go. And I asked everybody in class, what do you guys want to learn? I could teach you GIS, I could teach you, we could go on with Python, we could go on with C, or we could study for the final. And everybody said, let's use the 4 days to study for the final. So basically, I just gave them very similar questions that were going to be on the final. And that's what you guys wanted to do, that's what they wanted to do, so they all did well on the final. So it's probably going to be like that in here. Everybody in here is pretty sharp, so we might get a little ahead, don't worry, but you know, I think you're going to understand everything you need to understand by the end of the class. So let's look at descriptive statistics first. And this is something that you'll see, like, has anybody taken a statistics class before? That's something you'll have to take if you go on to get a computer science bachelor's degree. You'll have to take statistics. It's a really cool branch of mathematics. My wife is really good at statistics. Anytime I have a question, I always ask her. She knows this stuff. She's got a master's in marketing, but she understands statistics really well. We're just going to get into the real basic statistics. But when I taught a graduate level class in Unix, I taught that for like 7 years when I was at the U, and I'd actually have the students in the class write programs that would like take a whole bunch of numbers and like plot a graph and stuff like that, like manually, you know. And it was using a program called AWK, A-W-K, which is kind of like Python. So let's look at some of these statistics here. Oh, got the Chromie pen again? Oh, here we go. Good. So let's look at some of these, and then we're going to have a little class activity. Okay. So let's first look at the minimum. So these are things, you're going to take a bunch of numbers, say it's test scores. Got the minimum. Okay. So let's look at some numbers. Okay, there's a set of numbers. What's the minimum? What does minimum mean?
Lowest value,
Smallest. Yeah. So what's the minimum of these numbers?
-1.
-1. Okay. So the minimum just is the smallest. Okay. Then we have the maximum. What do you think the maximum is?
15.
15, yeah. Good. All right. So the minimum is the smallest, maximum is just the largest. What's the range? What is range mean?
It's -1 and 15.
Yep. Yep. Good, it's negative 1 to 15, right? Up in 215, right? So a range is,
So it's 14, right?
it would be
Or 13.
the values, or, yeah, the values between the min, I'll just call it the min and the max. Okay, so the range of all these numbers, and they're not sorted, would be -1 all the way through up to 15, -1 to 15. So this right here is called the range. Okay? And a range is a measure of dispersion. How widely dispersed are these numbers? So they're about, what, 16 dispersed, 16 units apart right now. So fairly dispersed. Or the measure of variability. So what if we had a bunch of numbers like this? What's the min? I know my commas are huge. What's the min here? -1. What's the max?
15.
Okay, so the range is the same. But are these widely dispersed? Are they equally dispersed, I would say? If we were to plot these points on the line, let's plot these, let's rough it out. I'll say 0 is maybe here, and then 1 is here, and 10 is about here. Okay, so we got, and -1, so we got a -1, we got a 0, we got a 10, we got a 15, and we don't have a 1, do we? 1, 2, 3, 4, wait, what am I missing? 5. Oh, we got a 5. So these are pretty evenly dispersed, right? They're kind of even, they're spread out, but these, let's say that's 0, this is 1. We've got a whole bunch right here, right? And 1 over here, right? So we still got a range between -1 and 15, but I would say that they are not equally dispersed, right? Can you guys understand that? Okay. So we're not going to get into much more than that as far as statistics, but this would, now I'm not going to talk about it. There's standard deviation and there's mean. There's other things that we probably won't go into. You guys know what the mean is? Or the mode?
The mean
Like
is
when you add
average.
everything up together.
The mean's the average, right? Right?
So the second example has a way lower average.
Right. So how do I calculate the average?
You add all of them and then divide them by the amount there are.
Right.
Yes.
Right. Hey, let's do that. What the hell? So 5 minus 1 is 4, plus 10, 14, plus 15, 29, divided by 3, 4, 5. Okay, let's do that. 6 times 5 is 30, so it's going to go on 5 times. 40. 8 times 5 is 40, right?
Yeah.
So we would say the mean of this, that x with the bar over is the mean, so it's 5.8. So in this case, these are pretty well dispersed, and the mean would be right about here. Right about in the middle, that's the mean, that's a pretty good mean. Now what would the mean be for this thing? I don't know how many ones we got here. 1, 2, 3, 4, 5, 6. Minus 1 is 5, and 15 is 20. Divided by 1, 2,
Wait, why am I doing
5, 6, 7, 8. 8 goes into 22 times 16, 40, 2.5, right? So the mean of that is way down here, right? Say that's 2.5 right there. So that's the mean. You can see it's skewed way over here. Okay? What's the mode? Anybody heard of mode?
Is it the number closest to the average?
No.
Out of the list of numbers?
No, it's close.
Don't you have to put it in
It's
order?
the one that appears the most frequently?
Yeah, most frequent. The most frequently occurring number. So what would be the mode here?
Positive one?
1, yeah. So this, the mode equals 1. Now, all these are available in Python with the statistics package. Does this have a mode?
No?
It doesn't, because there's no number that appears more than
the
once.
rest of it.
Okay. Okay. And I probably shouldn't have used the word set, because in Python, you could say, you could create some numbers like this. You could say my set equals 1, 1, 2, 2, 3, 3. And then you could say my new set equals set of my set. There's a set function, and sets don't have duplicates. So this is a good way to get rid of duplicate numbers. My new set would then be equal to 1, 2, and 3. It gets rid of any dupes if you use the set function. Okay.
So I got a question, so why would you have to do that when you're like prompting it? Like, I'm just curious, like, what does it do?
Why would you have to remove dupes?
Yeah, like, what's the function of it, like, why do you have to set it that way?
It's just, sometimes it's really good to just, you might have a problem, I can't think of one right now, but I've had to use it a lot. Like, you've got, people have entered duplicate numbers and you're trying to do something and you want to just eliminate them real quick. It just, this automatically does it. It just gets rid of dupes. I'm trying to remember, I know I've used it, I can't think of an example right now, but believe me, it's used, it's good.
I was curious.
Yeah. I'll think of something before the end of the semester probably that uses it. Okay, so these are the statistics. Minimum, max, the range. There's also the count. So what would be the count?
That guy on Sesame Street.
What?
The guy on Sesame Street?
Count Chocula? No. That was a cereal. Anybody
Yes.
remember that? And then the count on Sesame Street. 1, 2.
Oh, I was gonna ask for the my set. Does it delete duplicates for other data types too, like a string or something like that?
Yeah, I think it
It
does.
does?
Try it, test it, yeah.
That's cool.
Okay, so what would be the count? This is another statistic. What would be the count for this? 5, yeah. And this one we said was 8, right? 1, 2, 3, 4, 5, 6, 7, 8. So the count, there's 8 values here. So that's the count for that. And then one more, a simple statistic is the sum. And you guys know what the sum is, right? Just add them all up, okay? So these are the main, let's see, 1, 2, 3, 4, 5, 6, 7. Those are 7 statistical operations, okay? And we probably won't get into much more than that. Let's see, I think we can do this before we take a break. So there's a thing called a doc string. Doc string. Okay, a doc string. I don't know if I don't want to show you guys this yet, but I think I'll have to because we haven't gotten into functions yet. But a doc string starts with, it's a string with triple double quotes. Triple double quotes ends it. And I could just say this is a doc string. Okay. So, I'm gonna have to teach you a little bit about functions right now. So suppose we can write our own functions, and you write your own functions by defining them, there's a space. And suppose I'm gonna write a function called print hello. Okay, and it doesn't have any arguments. And I'm gonna put a docstring in here. And I'm just gonna say print hello. Triple. So the very first line, it's almost like a little comment inside your function. And then my function, this is a tab. And this is just a simple little function, and it's called print. And all it does is print the word hello. Not very valuable, but this is how you write your own functions. With a def, define, the name, any arguments, and a colon, and everything else is indented, just like we've always been doing. And then the way we invoke the function or call the function is just by putting the function's name. We would just say print underscore hello with no arguments, and that would print the word hello by calling it. I've written my own function. When I call it, this is called a call. This is a function call, you would say function call. It just is going to execute this. And if I said print hello, and I said to this, sorry. The way to get the doc string out, it is stored in an internal variable called underscore underscore doc. So whenever you create a doc string, it gets created in this underscore underscore doc underscore underscore. This would be a internal variable that you don't normally see. But I could say print, and I could do the print hello function dot underscore underscore doc underscore underscore. That's kind of weird. So this is gonna call the function. It's gonna print hello. This is gonna print the function's doc string, the dot. So it's gonna print hello, and then it's gonna print this is a doc string. And it's a little confusing. Can you guys see that? Did I print that too low? I just want you to understand what a doc string is. It's good to put those in once we start writing functions. Okay. I think I have an example here. Let me pull this up real fast for you. Okay. Let me make this a little bigger for you guys.
Is the function call together or spaced out?
And did I make this big enough for you guys to see? Okay, so this is a little tiny Python script. Hopefully you can see that. So I've defined my function print hello, and I have a doc string. It says doc string for the print hello function, and then I say print hello. So let me comment this out for now. I don't want to run this last line, so I'm going to comment it out. And I'm just going to call, so this is a function call. Now this is something that you haven't learned yet, but this is a comment. You could put a pound at the beginning of a line or a pound at the end. This is called an inline comment, and this is just called a regular comment. So you can put comments at the end of the line too. Okay. So let's call the function, and it just printed out the word hello, which we thought it was going to do. And now let me uncomment this, bring it back over here. And now let me clear my screen, move this up a little bit. And now we're going to call my function I wrote, and then we're going to print out the function and the doc. built-in variable. And there you can see that it printed out the doc string right here. So it printed out hello, and then it printed out the doc string. And I had a little space here, so you can see it printed out the space too. So that's what a doc string is. I just wanted you to understand it. It's something you put in functions to help you if you want to print out what the function does. There's another way you could do it. You could say, let me fire up Python here for a second, interactive. I could say print dot, I don't know if you guys saw what I did there, but let's see. Okay, so say I want help on the print function that's built in. So I said print, the print function dot underscore underscore doc underscore underscore. And it printed all the help that the print function, that I need for the help, for the print function. Okay, so that's kind of cool, right?
Print dot underscore doc underscore.
Yeah.
Okay.
Two underscores. So there's a built-in doc string in the print function that's built into Python. Okay. And now what I'd like you guys to do, I think while we're still thinking about minimum maximum, I've got a little in-class exercise we're all gonna do at our desks. And that is right here. Just up a little bit. So I want you guys to type this in exactly as it is here. Create a new Python file in VS Code, call it statistics.py. And create a doc string. If you're a fast typist, it shouldn't take you too long. And this is a little program that's going to find the minimum of 3 numbers. Okay. So what's this first line doing? Setting a variable number 1 equal to the integer of our input. It's going to say enter the first number, convert it to an integer, save it in there. Then it's going to print to the screen, enter the second integer, it's going to save it to number 2. Enter the third integer, and then you're going to type in, and it's going to save that value into number 3. So how do we find the minimum of 3 numbers? The hard way? Well, we just set the very first one equal to, we call that the minimum right away. We don't know what they are, but let's just set the very first one, and we'll say, we're assuming that's the smallest. And then we check the other 2 against it. Is number 2 smaller than minimum? If it is, we set a new minimum to number 2. If number 3 is smaller than our new minimum, then we set minimum to number 3. So we've checked all 3. And at the end, we just say print minimum value is, comma, minimum. It's pretty simple logic. So I want you guys to try this. And then you can take a break. Once you get it done, just raise your hand. I'll come around, make sure it works, and then you can take a 10-minute break. And it'd be good to save this, because we'll be doing something similar in our group exercise. Actually, I might as well put the paper up while I'm walking around. Uh-oh, what happened? Two papers left. Let's see who's the fastest typist in here. I could have been nice and emailed it to you, but I wanted you guys to type it. It's not that much.
Got it.
You got it? Tim?
Yeah.
All right, I'm coming up in a second.
Well, if it works right. Yep.
It worked?
Yep.